Hello, and welcome to this pre-class video for Chapter 6. You actually get me for once and not Stan this time. This is a section we skipped over, but we do have a little bit of extra time. This is something that if we didn't have time, we'd just skip over, but I wanted to talk about it. So this is what we're going to talk about for Friday. And the topic we're going to talk about is right here on the slide in front of me. It is the idea of calorimetry. So calorimetry is how we actually measure heat transfer, and so all these values we've been talking about how we know like enthalpies of vaporization or enthalpies of fusion or enthalpies for reactions. We need actual experimental data to be able to figure those out. Once we have that data, we can use things like Hess's law to find enthalpies for other reactions besides the one we measured. And so the experimental technique that's used to find these heats and heat release of processes, in particular reactions typically, is calorimetry. So a calorimeter is a device that is used to measure the absorption and release of heat. And what we do is we make a closed system. And so we have the calorimeter has some, so our system, which is our reaction that we're interested in, is going to generally be an exothermic. It could be endothermic, either way. It's going to either release heat or he's going to be transferred into the system, and we measure how much heat enters or leaves the calorimeter to figure out how much came from our system, either whether it's exothermic or endothermic. So what does this look like? A simple calorimeter would be something like this coffee cup calorimeter here. So we just have two things that are insulating. So a coffee cup that prevents heat from coming in or out, keeps your coffee warm or whatever. The basic idea is you have a lid on top. You close it up. You're trying to prevent any heat from coming from the air around the outside or anything around. And then you measure the temperature change with the thermometer. So for example, say we want to measure the temperature change caused by this reaction. How much heat is released when hydrochloric acid and sodium hydroxide, an acid and a base, react to form sodium chloride dissolved in water in liquid. And so we could imagine having 25 milliliters of HCl, add in 25 milliliters of sodium hydroxide, put the lid on, and measure how much did the temperature change after this process happened. So this would be a very simple sort of calorimeter. Again, what we're going to measure is how much did the temperature of our water change, and that can tell us how much heat was released. And so this goes through the reaction, what's delta H for the reaction, and this walks us through the calculation of how we do that. If we have 25 milliliters of 1 molar HCl in a coffee cup calorimeter, this is an example problem from your textbook, it starts at 18.5 degrees Celsius. After it reacts with 25 milliliters of 1 molar sodium hydroxide, the temperature rises to 25 degrees Celsius. How would we find the enthalpy of reaction for that? And we're going to need the heat capacity of water, the molar heat capacity, which is 75.3 joules per mole degrees Celsius. So first of all, we know what the balanced equation is, and we need to figure out how many. We have the volume and concentration of each of the sodium, the hydrochloric acid and sodium hydroxide. We also have the initial and final temperature. So this is the information we know. We're collecting and organizing information. So we know concentration, we know volume, we know initial and final temperature. So what do we do with this? Let's analyze what equations we're going to need. So we're producing water, so we can focus on the amount of energy in the water. And we assume that the density of the water is 1 gram per milliliter. We have to be able to convert to grams and moles. So the heat that the water is going to experience is based on the number of moles times the heat capacity times delta T. We've seen this equation several times now. And the reaction, the enthalpy of that reaction will be how much heat for the reaction per mole of reactant that participated. And these heats are going to be related to each other. The heat that caused the temperature of the water to increase is also going to be directly related to the heat that the reaction produced. So how many moles of water do we have? We take our 50 milliliters, use the density of water to find, right here, 1 gram per milliliter, and then we use the molar mass of water, 18 grams, to figure out we have 2.77 moles of water that we have. So because this comes from our 50 milliliters, we have 25 milliliters of 1 molar HCl and 25 milliliters of sodium hydroxide, so a total of 50 milliliters of water, approximately. There is some HCl and NaOH in there, but it's small compared to the amount of water. So how much heat did the water gain? And so, right, this would be endothermic for the water, right? The temperature is increasing. So we take the number of moles of water, 2.77 moles, multiplied by the heat capacity times the difference in temperature here. That gives us 1356 joules. We know that all that heat came from the reaction, so the Q for the reaction is negative 1356 joules, and then if we want to get that value per mole, we divide by the total number of moles of our reactants. So that would be 25 milliliters times 1 molar gives us 0.025 moles. That's where that value is coming from. So we get the enthalpy of the reaction is negative 54 kilojoules per mole. So the main thing to remember here is this idea right here, is that the heat that went into the calorimeter, in this case the water in our cup, came from the reaction, and so those heats are equal to each other. And one last thing to think about is delta H of the reaction should be negative. This was an exothermic process. It caused the temperature to increase because the heat that went into the water that was endothermic. So that's the heat was produced by the reaction, went into the water, caused the temperature to increase. Okay, so here's a summary of all those steps together. You can pause this if you want to just go through this again. So how do we do this in a right, for something simple like an acid-base reaction like that, our little coffee cup calorimeter works okay. But say we want to measure a fuel burning, something like gasoline, or what this is often used is food, right? You can burn food to figure out how many calories are in it. This is actually how you do that, to get the labels that we are familiar with. And so this is done using a device called a bomb calorimeter. This is a constant volume device, so it's in this this right here, the steel bomb. This is a big piece of metal, it's super heavy. And you have that's where you put your system, your reactants that you're looking at. And surrounding that is a bunch of water. And so that's the rest of the calorimeter. We again have a thermometer, we have a stirrer, and we have a way to start the reaction. So these wires for ignition. And so the heat produced by this reaction will go into our water that's around it. We measure that temperature change, and the heat received by the calorimeter is going to be the heat capacity of the calorimeter times the temperature change, and that'll give us the negative of the enthalpy for the reaction. So what do we mean by this heat capacity for the calorimeter? What we do is we measure a known reaction that produces a known amount of heat and see how much that causes the temperature to change, and that tells us the heat capacity for the calorimeter, how many joules per degree Celsius. So this won't have a grams or moles as part of it. This is going to be specific for each calorimeter. So this is something that you would have to be given. This is not a value that you would necessarily have to look up or anything. It's going to be specific to each calorimeter. So in a problem or something like that, you would be given this value of the heat capacity of the calorimeter. Okay, and that brings us to the end of this section on calorimetry. We'll go through some examples in class as well, but yeah, that's a brief introduction to the idea of calorimetry. I'll actually bring in a calorimeter tomorrow so that you can see what it looks like as well. So I'll see you in class.